And we're live. Hey, hello, welcome everyone. It's time for Blocktalk. We are on Bitcoin block 404, 916. So we're almost 15,000 blocks away from the halving. Oh man, it's really coming up now. This estimate here is completely off. I think we were talking earlier. It's going to be around the 4th of July, maybe January 1st. We'll see if we got a Canada Day or Independence Day block halving. Pretty excited. Got some killer sponsors to talk about today. Quadriga, it's the premier Canadian Bitcoin exchange, and they recently added Ethereum market and Ethereum Bitcoin market and Ethereum Canadian market. So if you feel at any point in the presentation today that you want to go and buy some, may I suggest Quadriga CX? There's a link in the description below. And also are sponsored by the Syscoin team. We had these guys on twice, and they've definitely blown us away with their decentralized marketplaces. And they recently partnered with Microsoft on their Azure platform, and they were so gracious to buy beer for everyone in our live audience tonight. So without further ado, let's introduce our main guest. All right, hi everyone, I'm Alex Dirk, and we have our guest tonight. We have Vlad Zamfir. Am I pronouncing that right?
Yeah, that's right.
So you are the chief architect of the Serenity, or no, it's not Serenity, is it? What's the name?
Yeah, it's just Serenity is the name of the release where we're gonna have Casper released. I mean, I'm not the only person working on it. I mean, Vitalik and I and Greg Meredith are, I guess, people who spend the most time on Casper.
Okay, but your role is the architect, I believe, or the designer?
I mean, I was the original architect and designer. Everyone is involved in architecture and design discussions at this point.
So when I hear the term architect, I think of that guy in the white suit with all the monitors and the matrix. You know, it's like this will be our fourth forking of Ethereum, and it's our most effective one thus far.
I mean, yeah, that's the idea. But yeah, I'm also working on blockchain scaling, blockchain sharding. And that's one of my main research focuses right now. That and Casper. I'm trying to work on minimizing Casper's overhead and then making sure that we have coverage on all the edge cases. So that's
very cool. So I guess you could be the guy in the room with all the monitors, and Vitalik can be Neo, and Vinay he can be Morpheus and taking the red pill. That's my terrible humor for the night. There'll be no more cheap jokes like that. And we'll have a big.
I'm sure everyone's laughing. Don't worry.
Yeah, we have our live audience at Decentral Van. Wave hello, guys. They're muted at the moment, so you can't hear their hysterical laughter that's coming from my awesome jokes. But hopefully after a couple more beers set in, we'll loosen the mood up here a bit. But yeah, I'm excited to hear a lot more about the newest thing, I guess, to come forward in blockchain technology, which is sharding.
Sure. I mean, I would love to talk about sharding. So the basic idea with blockchain sharding is that instead of having every miner or every validator process every transaction, you can process only a subset of the transactions, and we would try to maintain all of the guarantees that we have today with, about your transactions execution. So, in Bitcoin, it would mean like not double spending outputs. In Ethereum, it means that the state change that results in the EVM from your transaction is the result of the execution of the code of the contracts that you're communicating with. So there's like some kind of like normal types of guarantees that we want to provide in our blockchain that we'd want to provide even when not everyone is validating or participating in the consensus of around every transaction. So fundamentally, sharding is about having like different pieces of the state progress concurrently, rather than having everything be globally ordered and globally processed by everyone.
So rather than having someone store all of, say, Augur's data when they're only interested in, say, Slocket's data, they can kind of pick and choose whatever suits their fancy.
Well, I mean, you could do that as a full node anyways, but in a sharding solution, I would like to see something like, full nodes not deciding what shards they get to be on, because, there's a lot of important security properties that we need to make sure hold. And one of the most important ones is that there's never a monopoly on a shard. if there's ever one adversary that controls all of the data on a shard, then they can potentially do some bad things that we can't recover from. But pretty much every other failure mode we can recover from. If like a shard censors transactions or messages, or if a shard reverts and reorgs transactions, all of these things can kind of be dealt with on a cross-shard basis, where everyone will basically like respond to the fact that all of the outgoing messages from this shard from the last this many blocks are need to be reverted, and we need to replay these new ones or something like that. But basically, the important thing to think about in sharding is who is processing the transactions, and what guarantee do you have that the consensus on these transactions and the state after the transactions is going to be isn't going to be reverted, and like that an adversary isn't going to be able to screw with it. I mean, I feel like it might help if you had some questions, or I could just keep monologuing.
Well, sharding. When you talk about consensus, is each shard coming to their own consensus, or is the entire network having consensus at once?
Yeah, so it actually depends on the sharding solution. Different sharding solutions have different approaches here. But in my sharding solution, I basically have every shard runs its own consensus protocol, and then the shards run a consensus protocol between themselves. This is like the kind of simple sharding solution where you only have like two levels of consensus, one of them at the shard level and one of them at the global level.
Okay.
But for example, Vitalik's sharding solution is a little bit different. He has a consensus protocol at the global level, and which will select people to randomly audit state changes in shards, but the shards themselves don't have independent consensus protocols. They all kind of update in lockstep concurrently, in the sense that different shards update each in one lockstep, but they would all kind of update once with every global beat on the global level, top level consensus protocol.
Okay, so you were talking in another interview I saw like this the proof of stake switch would bring us down to like 1 second block time. So would like the higher level protocol still be on 15-second block times and be proof of work, or?
That's a good question. I mean, well, no, it wouldn't. I mean, so there's no reason for it to be proof of work or stake or anything in particular. I mean, sharding is entirely orthogonal to the public consensus problem. It just has to do with like consensus, kind of more generally. The rate of blocks at the top level is a question basically that the faster blocks you do, the more overhead there'll be, but potentially faster you'll be able to give clients guarantees. And so there's like trade-offs, right? If clients are willing to bear higher costs, they could have faster blocks at the higher level, but they would have lower transaction throughput, for example, perhaps. Basically, you can do faster blocks at a higher level at a cost. I don't think it's that necessary to do fast blocks at the high level. Basically, the ideal thing to do is to have the minimum amount of synchronization, but while still maintaining the guarantees that you want for your clients. In Ethereum's context, what that means is that your transactions will execute completely in a terminating execution, and they'll affect contracts only according to the execution of that contract's code, or it will run out of gas and be entirely reverted, with the little exception of the gas payment being forfeit. So that's like kind of the Ethereum atomicity thing, and that's definitely what we want to provide in a sharding solution. And the other thing that we really want is shard transparency. So shard transparency refers to the idea that when you make a transaction or when there's like a message between contracts, they never know or refer to the shard that contract, the destination contract, is sitting on. The fact, we don't want to add shard IDs to the development environment. Right? The EVM should never have like a shard ID opcode or something like that. So shard transparency and making sure that we have atomic transactions, even when these transactions cross many shards, are kind of the two main priorities that I have for this blockchain scaling solution. And the other thing is that it should be able to recover from most failures of shards.
Okay, so like how transferable are these shards? Like, can you have one on a test net and then easily transfer it to the main net?
No, you can't really do that because the validators from the shards and the contract on the shards are going to be churned by the protocol, so that it's going to be difficult to, in an effort to make it difficult for anyone to have a monopoly on a shard. So if you get to decide like what state is on your shard or who is validating on your shard, then you could potentially much more easily have a monopoly on that shard. And then you would be able to violate atomicity guarantees, or at least prevent transaction finality.
So would we see something like pruning involved in shards as well, or is shards kind of a better solution to actually like scaling the blockchain to smaller clients?
So pruning is a good idea in general. I mean, but it's an orthogonal thing. I mean, you could do that and sharding. Sharding is a nice scaling solution because it scales the protocol at the protocol level. It doesn't kind of strap something onto the protocol in order to scale some feature of the protocol. So the problem with like Lightning or like netting without settlement in general is that it makes censorship more profitable. If you're able to censor the blockchain, then there's not going to be any settlement potentially, right? And so you just like censor these settlement transactions until the check lock time verify kicks out, and then you can basically double your money. So Lightning makes it more profitable to censor, and I think if you make something more profitable, you make it more likely. Sidechains make it more profitable to double spend because you send some coins to the sidechain and then you like send them back to yourself, and unless the sidechain forks along exactly to replicate the fork in Bitcoin, then you're gonna have assets on both chains. And that so basically like sidechains make double appealing to me, but sharding is a solution where actually you don't lose any economic guarantees in terms of and the trust model doesn't change at all. You don't have to have like different trusted nodes or anything like that. The authentication model is still basically the same. You still basically have like, if we have more than half of the, the fault tolerance assumption doesn't really like, fault tolerance analysis is like basically an extension of the fault tolerance analysis we do in a single chain setting.
Interesting. So I don't know if anyone from Decentral maybe has a question on sharding as well, but they might have to figure out how to unmute themselves. There you go.
I got a question. Has there been any sort of statistical analysis about sort of how to do shards efficiently, like thinking about a CDN and also just general payment networks in the traditional sense? They work geographically. Is there any kind of step towards that, or is it just random, like a DHT based on a hash?
Yeah, so for now we're keeping everything pretty random because we want to make like the simplest scaling solution that still has like these economic security properties. Once you want to have like what I call heterogeneous shards, where shards aren't just assumed to like all have the same property, like the same capacity and the same, exactly the same, providing exactly the same services. If you have heterogeneous shards, then you can start looking at geography and other factors, perhaps like performance, latency, whatever. And that's something that we're totally interested in doing, but it's definitely not the first thing to do. And so it's like basically, and there's basically like two tensions, right? If you let people have shards anywhere and like self-defined shards, then maybe you'll have more efficiencies, but then you're more likely to have a monopoly on that shard. And when you have a monopoly on a shard, basically you can do invalid things without producing evidence of it because you can censor the fact that you've done something bad. Whereas if you're in like an oligopolistic market or a competitive market, if you are malfeasant, it will be discovered. If you're malfeasant in a way that like reverts blocks or makes invalid blocks or whatever, something like that.
Thanks.
I just want to comment on your comment on Lightning Network. It's only more profitable for miners to censor transactions if they have like all the miners are colluding to censor that transaction.
Yeah, well, I mean, you need a majority. You need a majority of hashing power. You need to have a majority of the blocks.
But you need a supermajority. You need like all of them because.
No, you don't actually. Not really, because actually, because as soon as you have a majority, you can censor all the other miners. And then you get an increased block reward after difficulty retargeting, which is kind of cool too.
So you're saying that's a 51% attack?
Yeah, it is totally a 51% attack, yeah.
Well, Bitcoin's broken if there's a 51% attack.
Agreed, yeah.
I know there's this kind of like proof of work, proof of stake debate. Being someone who's been working on proof of stake so long, what are your thoughts against kind of like maximalists like Paul Shork or people like this, and maybe also like maybe just pros and cons of both.
Sure. So this is like a good place to start segueing the discussion from sharding to Casper. So I guess I just want to know if anyone else has any sharding questions first, and then we can totally go into this. No more sharding questions? We all good?
I just a quick question. Sorry. Hi.
Hi.
But in terms of, so can you give a quick analogy of what the difference between the current chain right now with like sharding, because you mentioned like parallelization and concurrency, and that immediately brings into face of like art stepping, lock steps, and the usual problems with data parallelism. So it's just like,
yeah, I mean totally. Like there's all sorts of relevant work in distributed databases that like deals with concurrency of transactions, and it's relevant. Although it doesn't, so I'm not aware of any work that involves transactions that affect stored procedures that can communicate with other stored procedures in the database. So like the Ethereum ecosystem is a little bit different than the most of the distributed databases that I've seen, but yeah, totally. I mean, all that stuff is very relevant to this blockchain scaling discussion. Basically, we need to execute transactions concurrently as much as possible, and we need applications that are deployed to the sharded blockchain to be written in such a way that takes advantage of the fact that they can have different pieces of their logic be executed concurrently. If you write your application entirely in one contract and you do it all in sequential logic, then you're not going to get any gains at all from the scaling solution. At very best, you can have your contract be the only contract on a shard. But if you want your application to scale beyond the capacity of a single blockchain, then you have to write your application in a way where it can deal with processing user requests concurrently.
In terms of these actual shards, I mean, is there never mind. Sorry, brain part.
I've got a quick one on just sort of cross-chain applicability. Like, how much of what you're kind of architecting takes advantage of Ethereum, and how much could say it applies to Bitcoin? The sharding work specifically.
Yeah, so the sharding work, a lot of it does work with pretty much any consensus protocols for the shards and for the global consensus. There is stuff that is somewhat more elegant in proof of stake than in proof of work solutions. But if you just use like the naive kind of like Nakamoto style consensus with proof of work, but there are other proof of work style consensus where you do get some nicer features. So let me take a step back and tell you what I'm talking about, which is there are certain cases where you'll want to penalize people. So like if a shard produces an invalid block and everyone is forced to revert blocks as a result, you want to penalize that shard. In proof of stake system, we like remove their security deposits. In a proof of work system, it's a little bit tricky if the proof of work is outsourceable, so you have to switch to a non-outsourceable proof of work, and then you have to like delay block rewards in order to like say withhold paying them if it turns out they did something invalid. Or the other idea to use proof of work for this type of system is to have identity towers. It's like this idea that Dominic Williams has had, where you use a whole bunch of proof of work to create an identity essentially that you can use as in a consensus forming node. And then if you did something bad, then you would lose that identity, and you would have to spend a whole bunch of work to make a new one. And you could do that potentially with Bitcoin miners today. I mean, you just have to like rig them up to be like mining these identity chains in order to make identities rather than this outsourceable work on blocks thing. So a lot of it is applicable. Definitely reasoning about this stuff helps you think about sharding proof of work and blockchains and crypto economics in general. So I definitely think that like this research is relevant. It's actually a lot easier to shard Bitcoin than it is to shard Ethereum because of the nature of the application state. I mean, if you have two different outputs, they can be spent concurrently. If you have them at like one state, and so like managing the shards in Bitcoin is quite a lot easier than on Ethereum.
So you're in favor of applying shards to Bitcoin rather than sidechains?
Oh yeah, totally. I think sharding is way better, way more elegant than sidechains. Because again, sidechains have this problem that they either make double spending more profitable or they have to fork when Bitcoin forks. Whereas sharding just provides like in-protocol scaling. But the issue is that it obsoletes existing mining hardware unless you use these identity towers instead of proof of work directly for consensus. If you use this identity towers thing, miners could create identities, which could then be used in like a BFT protocol that has like fault detection in order to punish people for doing things like invalid blocks or preventing consensus or whatever it is.
Well, I guess this really just goes towards the maximalist argument where almost every altcoin is a testnet for Bitcoin.
Yeah, that's what they believe, but it also has to be true that Bitcoin is able to hard fork to these new protocols.
Yeah, that seems to be more of a flaw with just the human beings trying to implement Bitcoin rather than the protocol itself.
But I mean, it might be a flaw in the maximalist philosophy unless you can like justify to yourself that we will be able to keep up with with basically technological change.
Interesting. I've got one question from YouTube here from Nahima Marshall. What is the latency impact of homogeneous sharding versus non-sharding?
Versus probably non-homogeneous sharding, maybe.
What is the latency of homogeneous sharding versus non-sharding?
So whenever you think about like latency, you have to ask exactly what you mean. So like in Bitcoin, latency, there's like you get a 0 conf and then 1 conf, 2 conf, 3 conf, and they take like some random amount of time, and then your latency to enough confidence might be like 6 confs or something. In like Casper, I think we'll have like very quick confirmations that like ramp up to like very high security somewhat quickly. But I can't give you like a number. I imagine that like your first confirmation within a few seconds, and then like finality, within a minute, definitely. At least in the happy face case where there's no network partitions or network asynchrony or large number of faults trying to slow down consensus.
Okay. One other question that I had from earlier was what do you expect the average user will have to host on their computer in terms of size with sharding?
So that's a good question. I mean, so the goal is to have heterogeneous sharding eventually, and with heterogeneous sharding, we'll be able to have the space between like the weakest node and the largest node and the strongest node on the sharding solution to be quite large. In heterogeneous sharding, though, we basically will have some standard size of full node that is running on the Ethereum network before we implement sharding, and we'll assume that all of the nodes will have that capacity. And so if you have a really big node, then you're going to pretend to be 5 nodes, and you might like live on 5 shards. But eventually we're going to have heterogeneous validators and heterogeneous shards, and so it doesn't matter. It won't matter how big or small your thing is. You'll be able to connect it and participate in consensus in one way or another, as long as there's going to be some minimum capacity required, obviously.
So there'll be maybe like a little slider in the wallet of how much you want to contribute.
Yeah, I mean that would be nice. And ideally you would like figure out what is most profitable to contribute or something. But at this point, this is kind of science fiction.
Mm-hmm. Oh yeah, we're definitely breaking some new ground. So I don't know if we have any final questions on sharding. Decentral.
So the main things again that I really want for the Ethereum sharding solution is that application code and users don't need to know on which shards their contracts are sitting, and that transactions are atomic. Like every transaction is either complete a complete terminating execution of contract code, or of EVM transitions, or else it is reverted entirely and is out of gas. And then a few other things are like load balancing. We want to make sure that if this shouldn't really matter on which shard you are in terms of how much gas you're consuming or how much revenue in terms of fees you're making. So that's basically what I'm trying to do with my sharding solution, which I'm still working on documenting. And most of the protocol is guaranteeing atomicity of transactions, because it's quite complicated when shards start being Byzantine. To deal with all the possible exceptions.
One last question on sharding. Maybe my thinking is perhaps a bit sort of Bitcoin-centric. I'm not an Ethereum expert, but how would the kind of sharding be determined? Would it be determined by the sender or the receiver of a, let's say, payment? I know Ethereum is slightly different, but is it just like the creator of the contract that determines the shard, or?
No. So the idea with shard transparency is that you would never need to know, or you would never be aware of which shard your contract is on. You would deploy it to some shard, or you wouldn't really know. You would deploy it to the blockchain, and it would find its way to some shard, and then it might move around to other shards. And when you talk to it, you don't talk to it through a shard. And I think that will be really good for application developers, because they're not going to think about that. In terms of Bitcoin output spends, the question is, okay, do I need to know which shard my outputs are on in order to spend them? Is there a rule, for example, that I'm only allowed to spend outputs on the same shard in one transaction? I mean, when I worked on a little sharding solution for Bitcoin for the Scaling Bitcoin conference in Montreal, I basically had a rule where your transactions had to spend outputs from a shard, and it got to choose which shards the outputs of that transaction go. And so that's not so much shard transparency, but it still does. It gives you an idea of how perhaps you could shard Bitcoin. So if you're not worried about load balancing or transparency, you could do something like using the first few bits of the output to decide where on which shard that output sits, and say that a transaction can spend outputs from a shard to other shards, and all shards need to become aware of the outputs coming into their shard, and only do valid spans out of their shard. And then the tricky thing is basically making sure that that the security is kind of reinforced, right? That you can't just if you corrupt one shard, create 1 million bitcoins through some invalid thing. It has to be that the fault tolerance is still 50%, or at least close to.
Okay, thanks.
Whoa, let's move on to Casper.
Sweet. That marks the 7 minutes and 30 seconds. 30 minutes. So, oh God, it's 7:30. We're halfway there. It's a good time to search Casper. That's what I'm trying to say. So you had asked generally about proof of work versus proof of stake, and what I was going to say is basically kind of on a high level why I'm why I prefer proof of stake over proof of work. Basically, the proof of work security model is that the network will always spend more electricity than an adversary will conducting an attack, and so the network will be secure because they'll always be doing more work than an adversary. In security deposit-based proof of stake, the idea would be that usually people are just paying interest on deposits, but adversaries, when they conduct attacks, pay for entire deposits to be lost. And so most of the time it's really cheap for everyone, except for the adversary during an attack. So the idea is that we want to kind of move to a model where we want to measure security not in terms of the kind of fault tolerance, but in terms of the amount of money an adversary would lose if they to attack the protocol. And using security deposits could potentially make this quite a large amount of money, because they would have to incur a much higher expense than honest nodes. And so it wouldn't be that they just need to have 50% of the expense of the network. They'd have actually potentially much, much greater than that. Again, because they have expenses that an honest node wouldn't. Whereas in a peer proof of work system, everyone's expense is kind of the same because the cost of making a block is the same. The main criticisms that people have of proof of stake usually has to do with the fact that you have to have a slightly different trust model. Right? You have to kind of know who currently has coins in order for it to be economically secure. Because if you only know like the Genesis block, you know, those coins might have long parted those addresses, and someone could have found those keys. However, you know, they might have bought them. They might have hacked into some old machines or something, hacked into an exchange. Who knows? And then those keys could be used to conduct a long-range attack. And so there does need to be a change in this security model, the like trust model, the authentication model, to do proof of stake in an economically secure manner. Specifically, you need to know who has deposits when you synchronize with the chain. So it's like you need to have something from the consensus before you can synchronize with the consensus. But once you have it once, then you can update it yourself without ever trusting anyone. So you can learn who the new people with deposits will be from the current people with deposits, and so you'll kind of be able to update this essentially one public key for the whole blockchain without with the public key itself. But if you're offline for too long, then you won't be able to do that because like the people whose signatures you can trust are no longer bonded, and so then you'll need to you'll need to figure out who's bonded in order to synchronize with the network. And so that's one of the main things that people don't like about proof of stake. I think that it's fair enough. It kind of would be nice if you didn't have to get some piece of information before you synchronize. But I think the efficiency gains that you get from being able to use digital assets rather than external assets as an anti-Sybil mechanism are quite high. Basically because our ability to punish nodes is a lot higher, and our ability to determine the payouts of the system is quite a lot higher. One of the main things that I really like about proof of stake is that, specifically security deposit-based proof of stake, is that if a validator is being censored, say if a majority of validators get together and they censor the minority, I can actually kind of somewhat infer that at the protocol level. Like I see that there are no blocks from a certain set of validators as being accepted. Whereas in proof of work land, because the anti-Sybil asset is external to the protocol, the protocol doesn't have any access to missing work. Orphan blocks are not ever, part of the protocol, and so like you can't really punish censorship in a proof of work system because this anti-Sybil mechanism isn't actually directly in the protocol. It somehow exists outside the protocol. It also makes it easier to reason about, and people like that. But I think that these kind of more complicated, but I would say like more sophisticated systems are going to become more and more understood, and like people will start to see why it's so much more efficient.
So what you were saying before was if you were seeing that the validators were having an issue with one particular node, you would actually intervene. You yourself would intervene at the protocol level. Is that what I was hearing, or?
Sorry, no, I didn't understand that. So if say 80% of the protocol, say 80% of the validators censor 20%, the protocol itself would be able to notice that, and like the protocol would punish them. I mean, I wouldn't personally, do like hard fork them out of the protocol or anything.
Okay, no, I was just kind of curious, just the wording that I heard there. But so if say a large majority of the funds wanted to control the network, and then make a smaller minority of the network actually look like they were attacking the network, so they would then lose funds, and then and in turn they have less strength. Isn't that kind of a way that the network is, or the whole game theory of this is broken? Like,
yeah, so there are expensive attacks that do hurt your adversary. So I could lose money in order to make you lose money in Casper, and that's basically I need to choose between that and the majority coalition finding it very profitable to censor.
okay.
I generally believe in using oligopolistic market models rather than competitive or monopolistic models. I mean, people. I don't want to assume that there is no concentration of mining power or stake I want to assume that there's a small group of people who can essentially collude and have a supermajority of the consensus forming power. And I want to deal with like failure modes really elegantly in the sense that it should be really expensive for the thing to fail. And so even if you have a majority, the right thing for you to do would be to be nice, right?
But like from what I was hearing, it sounds like you need to have a lot of the controls in friendly hands. Like the foundation has a lot of funds that they can in turn use to secure the network.
No, we don't need that. Actually, the amount of friendly funds we need is relatively low compared to something like half of the network that you need in a proof of work chain, because undermining the security guarantees of the chain is quite profitable in proof of work, but it's quite unprofitable in Casper. So the safety margin, if all you want is the adversary to have to spend a lot of money if they were to attack, is quite a lot lower. I don't know. I felt like I had a train of thought that I lost.
Oh, I'm sorry.
No, it's okay. It's not your fault.
Sounds like Decentral maybe has a question on this discussion, though.
Just a general question in terms of the rest of the field. I understand there's some sort of altcoins out there you do stake sort of in a while. What are your thoughts on the systems that are out there and running, and what are they getting right or wrong?
Yeah. So most of the systems that I've looked at, I mean, all of the systems that I've looked at that are out in the wild, work under fault tolerance analysis, but not under economic analysis. And some of them, don't even have that much fault tolerance. But the idea is that if you assume that more than half the coins are always going to be good, then a lot of these things work. But if you aren't willing to make that assumption, if instead you want to see that any attack has to be costly, given that like the majority of nodes are happy to collude, all of these protocols fail. I mean, all of them have profitable censorship, transaction reversion. Only Tendermint is a blockchain that's out there that has punishment for reverting blocks. Tendermint it's not like deployed as a public blockchain, but they do have like code and stuff.
What are the main differences? Because I was looking into Tendermint a bit, and I realized it's like for private chains. What are like the challenges that you have to face with doing this with a public chain?
Yeah. So the main thing that I worry about is market concentration, right? I really worry about the concentration of validator power of like security deposits, right? I worry that, and that's the main thing, right? The main thing is that it's really hard to guarantee a fault tolerance assumption in that environment, and so you need to reason under kind of economic models rather than fault tolerance assumptions. Because if you have market concentration, then it's really difficult to say, no more than a third will be Byzantine ever, or like no more than half will be Byzantine. So I mean that's the main concern in public systems is that it's much harder to guarantee the fault tolerance assumption that you need for your consensus protocol to work. Because an assumption isn't a guarantee, right? People often kind of wave away comments about 51% attacks because it's broken in that case anyways. Therefore, we don't need to think about it. Oh, hey, there's Ethan. Hey guys. Ethan works on Tendermint.
Oh, speak of the devil, yeah.
Yeah, we've been hanging out. He just needs his charger.
Okay. No, he doesn't want to weigh in on the pros and cons of Tendermint?
No, he can't hear you.
It's all good. We'll get him on a future Blocktalk, and we'll hear more about Tendermint.
Right. That's a good idea.
Yeah. So what about hybrid chains? Like I know one that's recently come out was Decred, and they have like a hybrid of proof of work and then the proof of stake actually like vote on every block to be validated.
Sure. I mean, I think that like hybrid approaches do have like some nice features. I mean, like if you did like a consensus protocol on top of a proof of work chain, then you can have, for example, better DOS protection, but still have fidelity pretty quickly. I think there are benefits, but I don't really believe that proof of work, is that efficient. And so for a lot of these protocols, I think that like you could think of ways to engineer the proof of work out and have it just be better as a result. There is one use case for proof of work though, which is anti-spam, and I think that is going to be valuable for lots of decentralized protocols. I mean, proof of work is just really good for anti-spam.
General question, not related to the last topic. Just I was taken by your comment on crypto economics, just as a phrase. How do you see like funding for that, in this kind of research and as a field going forward? Do you think it's going to be a kind of major field that people have PhDs in crypto economics?
That's a good question. I mean, I definitely think there's going to be more interest because I think there's actually something there, right? So I think that I think of crypto economics basically as providing information security guarantees using economics and like mechanism design. And so I think that cryptographers will get on board. I think that mechanism design people will get on board. I'm not sure how it'll be funded or how many PhD programs it'll be on what time frame, but interest is definitely there, and I think it's there for a good reason.
Sorry, I might take this opportunity to send some beers on behalf of the Syscoin team to Decentral because I think they're kind of thirsty at the moment.
Thank you, Stucky. Thank you, sponsors.
How many do I need to send? How thirsty are you guys?
Let's say 5 to be safe.
5? Okay. So through the power. Oh, not 15 bitcoins. No, I don't need to send that. Okay. 1 second here.
Wait, 5 beers for 6 people? That's at least 7 people there, actually.
Let me just send a blanket amount and see what comes out. All right. So through the power of the Bitcoin blockchain, no need for Slockit, we are managing to send some beers from me near the Waterloo, Ontario, all the way out into Vancouver.
Thank you. That was successful. Vending machine engaged.
Perfect. Good pitch for it.
Sweet.
Yeah, Internet of Things pioneers down here.
Hey, have you guys managed to get the brew done yet? We needed some decentral beers ready.
We bought some bottles at IKEA, but it's still brewing right now.
I think it's almost ready. I'm gonna check the name. Never done it, but we'll see. Might be shit, might be good.
Well, we'll be sure to seal them with a proof of asset of some sort, so you guys can show proof of your work for the bottles of beer.
Getting back on topic for that last question, how is like the Ethereum Foundation shaping up? Is it still pretty good in terms of funds? I know they were spending at a high rate, but now the prices kind of compensating for that.
Yeah, and we've also cut down our spending quite a lot since since the Homestead. Since the months coming up to Homestead. I mean, the Ethereum Foundation is like kind of much tighter ship than it used to be, and we have more funding. So that's like a good thing. In terms of the foundation, I mean, we're going to focus more on research, and I think things are actually looking quite better than ever on the foundation, actually, which I'm pretty happy about, because I think the foundation's health is really good for developing hard forks and deploying them and having the community go with them, as long as the foundation can stay basically as a center for Vitalik to do his thing. I think that we'll have that.
Good to hear.
In regards to consensus, so exchanges are at like 50 confirmations right now for validating that Ethereum has been transferred. With the proof of stake swap, will we see that come down, or is just the way the consensus is achieved in the network?
Yeah, so the idea of a confirmation will kind of exist, but the type of confirmation is going to be a bit different. I mean, it's going to basically go from 0% to finalized, which is I guess 100%, but it's, even before it gets to 100%, in some sense, it's finalized. And so I imagine that exchanges will accept finalized transactions, and I think it'll be quite a bit faster.
Interesting. That'll be good for arbitrage opportunities.
Yeah, I think that will be good. Actually, it'll be easy to move. I guess you're thinking arbitraging Bitcoin.
Yeah. Well, like for the most part, a lot of people use Bitcoin and Litecoin to do arbitrage. Well, Litecoin more so because it is that slight bit faster. But like that was one of kind of the cons of Ethereum not being used to displace Litecoin was because this 50 confirmations was still putting it at about 10 or 15 minutes to actually have exchanges validated.
Yeah, and at this point, it's still kind of early, and so it's not a bad idea for us to have this 50 conf thing.
Yeah, and it sounds like that was implemented more as a safety procedure, just for like catching any issues.
Yeah, and it's also it's really good to be careful about this kind of thing because it is proof of work blockchain after all.
So Alex, this being Blocktalk and traditionally a trading show, do you want to just give us an update on what you're hearing on the street? Trading Ethereum and altcoins. What's the word on the street?
Well, the ICOs regarding Ethereum have been like taking off like crazy, and actually I was really wanting to hear an official statement from the foundation on regards to Lisk, which was JavaScript programming that was supposed to be a more efficient way of doing contracts with Ethereum, and more user-friendly, I guess, for developers. They raised 15,000 Bitcoins, I believe, so right up there with Ethereum's original crowd sale.
That's incredible.
And it's only a two-man team, one of which is actually an IT manager for a bike shop, and the other one I don't think has much development experience. So
that's incredible. Wow. I mean, I've never heard of this. What is it called?
Lisk. L-I-S-K.
Oh, I have heard of this. Yeah, I don't know anything. I don't know very much about it. I haven't looked into it. I definitely can't make any kind of comments on that.
Okay. And then what was the other one that I guess went really crazy? Well, everyone's buzzing about Slockit, and but I think in terms of people talking about the value of Ether, like me and Kiko were even mentioning before that the mining costs are just well above like what the market, like the mining production rate is. The production rate is well below what the cost of are on the exchange is. So you can pay off graphics cards rather quickly. But I guess this is kind of going towards other coins that I've seen that have gone to proof of stake. There is a sudden surge in price because it kind of promotes hoarding. Like everyone knows that the coins are going to be more valuable because you're going to need them to produce more coins.
Right, and so they don't sell them to cover their expenses. Instead, they just kind of like decide, we'll sell as little as possible. Yeah, I certainly don't want people to get the idea that they will be highly profitable if they stake in Casper. I don't think that is something that I have. Like that's not really a guarantee that I can make. And I don't know also when Casper will be ready for deployment. I don't know, but we will be deploying it in kind of stages, and there will be like a stage where we bring down the block rewards, even before Casper is fully implemented.
Okay, so no word on what the inflation rate will be for the proof of work, or proof of stake implementation yet.
No, I mean this is something that is still very much in debate. I prefer not having any inflation whatsoever. Vitalik likes to have a scoring rule that determines the inflation based on like how well things go, and so if everything goes really smoothly, there's going to be more inflation than if things don't go as well. And if things don't go well at all, then people will be losing deposits on net. So that's still to be seen, but it's almost certain that there won't be like fixed inflation rate.
Interesting.
Vlad, what at a minimum does Casper need before it's ready to go onto the live network?
Right. So I mean, the main thing that we need is proof of convergence of our betting cycle, and then coverage of all the edge cases and failure modes. And we want to show that like full nodes don't just crash, so they have like bounded overhead in all possible scenarios. So there's still, and then obviously it has to be implemented.
Right, crucial detail.
I mean, Vitalik has already implemented a second proof of concept, and he's working on a third. And some of these proofs of convergence, for example, will be something that, like, ideally we'd have the proof of convergence on something that is either in the code or can be mechanically translated into the implementation, so that you know that the proof still applies to the actually implemented validator.
Okay. And so you're going to run it on a test net for a few months before...
Yeah, I mean, we'll definitely run it on a test net before it's launched, for sure. I mean, and we're going to launch it in stages as well.
Right. Okay, so how does it, launching it in stages, like, what does that look like?
Great. So the way that Casper works is it has these, like, betting cycles, which kind of are used to bet on which blocks will be executed at which heights, and then on which states result from the execution of these blocks. And so proof of work right now, it does kind of both. It gives you both the block that's going to be executed after, like, the parent block and the state that is that occurs afterwards. So what we're going to do is have, like, betting on the state on top of a proof of work chain, and then betting on the blocks on top of a proof of work chain, and then we'll remove all of the proof of work altogether.
Cool.
And add the proposers, who are basically, the validators going and proposing blocks without any proof of work on them. But that's something that, is still also not 100% set in stone.
Oh, I might have pushed a button. All right. Cool. Any other questions?
Theoretically, I might have missed this already, but theoretically, is it said that this would the chain would never fork ever?
No, that's not said at all. That's something like you can say about Tendermint, but you can't say about Casper. So Casper favors availability. So if, for example, there is, like, a partition, Casper is going to give you blocks and confirmations on both sides. And if there's, like, a remerge of the partition, one of the will win. And so that's, like, very much like forking. And also you'll have forking, definitely you'll have forking if blocks come faster than network latency, which is something that I hope we'll have in, like, some version of Casper. Pretty unlikely that we'll see that in the first implementation, but ideally, definitely we want. Casper, was designed from the start to handle sub-network latency block times, and that inherently involves forking and reorging. Sorry, it looks like you're speaking, but I can't hear anything.
Sorry, how can Casper achieve even faster block times of, like, 1 second, like maybe like worldwide ping is maybe up to that level? Like, I understand uncles are a large part of the protocol, but
yeah, so the uncles are actually not the main way that we achieve sub-network latency block times. The main way that we achieve sub-network latency block times is through reorgs, right? I mean, and uncles actually do lead to reorgs. A reorg is basically, I'll execute this transaction at this height, knowing that maybe I'll receive some transaction that I must execute at a lower height, and so I'll have to re-execute my later transaction. And so the execution of my first transaction was kind of highly speculative in the sense that there could have been another block coming across the network that gets in before mine, and that, like, is fine. Basically, so as long as you don't insist that all the blocks are chained together sequentially, you can have people kind of compromise and agree that, this is the order that we're going to execute the transactions on. And for certain applications, the optimistic execution of the transaction will work out in the first place.
Okay, so I guess that kind of goes with my earlier question about, like, consensus being, like, achieved differently in Ethereum, where it's not just it's like more of a gradual thing. But you were kind of saying it goes from, like, 0 to 100% right away.
I mean, and right away, meaning, like, within minutes, not necessarily, and that's, like, if everyone's connected to each other and the network's working, definitely, like, things can't even close to be 100% before they propagate across the network.
Okay, but it's not the same finality that we're kind of used to in a lot of these traditional blockchains.
So no, when finality is like the finality you're used to, I mean, you're not going to get finality at a sub-network latency time. I mean, finality is only going to come after the network sees it, and the network has to see that the network saw it, So finality is not at all what I'm talking about when I'm talking about subnetwork latency blocks.
Okay. Interesting. All right.
Yeah, subnetwork latency blocks are very much non-finalized. And so the 0 to 100 is like a sliding scale, right?
Okay. Well, yeah, I know. I'm just trying to, I guess, wrap my head around of like when people even talk about proof of stake or proof of work in a lot of the older chains, it's like you can't go less than a minute or else you start getting a serious problem with orphans. So like, but now we're all kind of accustomed to like Ethereum being these 15 seconds. But yeah, the 1 second is just mind blowing to even consume or even think about to have that kind of transaction coming through, or what for that kind of block size too.
Yeah, I mean it is you know quite a bit different. But to me, like you know, if you're gonna make a consensus protocol that favors availability, like as Bitcoin does, you know, it's really good to invest in making it be as low latency as possible because it's really consistent with the philosophy of like you know choosing forks. But definitely we have a relationship which is that lower latency means higher overhead, and higher overhead means lower capacity. And so actually going for lower block times means that you can do less transactions per second.
Okay.
So there's definitely trade-offs there.
So I got a couple questions here too, actually from one of the exchange operators. It's like from Bittrex. I would like to know what kind of functionality exists in Ethereum to support all these dApps in a standard way. For instance, Slockit wants to support the notion of that a holder of a DAO has the right to vote until the time of their trade on exchange happens. I can see how I can see how more coins will develop custom functionality like this on top of ETH, but I'd like to know that the Ethereum team has a vision of how they can create this in one in some standard way so that they're not building one-off functionality for every dApp. So are you guys kind of policing the way that like dApps are going forward and how they're doing their tokens?
We've spent a bit of time thinking about like coin standards and token standards, and we do have like a standard for an API for subcurrency contracts. But I definitely, you know, at this point we're not like heavily involved in making standards for all these exotic coin types that people want to make. I mean, definitely, I share his feelings, but to make standards or something, you have to understand it really well, and I don't know that we're ready there. We're there yet for like custom coins.
Okay. And the other thing regarding these DAO tokens, so in something like NXT, their coins are burned, I guess, into new tokens. But Ethereum, it's used as gas, so like they have to continually burn tokens or like pay for these DAO tokens to exist. Is that correct? I guess.
It's not really being burned, right? I mean, gas goes to the miners or the validators.
Okay, so but like this is the more DAO tokens that you have, in theory the higher value that Ethereum will have because more of them are being locked up.
So I'm not sure. Are Ether being locked up when DAO coins are locked up?
Yeah, like well, if you have a lot of DAOs being created or a lot of DAO tokens being created, you have a lot more gas being consumed.
Oh, potentially, yeah. Potentially, an increase in gas demand could affect the economics. And I mean, ideally, as far as I'm concerned, you know, in a scalable blockchain environment, the demand for gas could get high because we could actually have high capacity. I mean, for now, we're only offering like a few million gas per block, a capacity on the network. So. It's not that conceivable that would have a big effect at the moment.
Okay. All right. No,
but what could happen actually is people could start having a bidding war, right? I mean, the gas price could go up, and that could potentially start to lead to a sizable demand. But you know, no one really wants to see that. We definitely really don't want to see you know, the gas price have to go up because we reach capacity. Ideally, we'd be able to you know, increase capacity before that happens.
Well, I think that was a lot of people's feeling with the price going up. It's like, oh, well, the gas price hasn't really adjusted. Now it costs
Yeah,
me a
well,
lot of money.
we adjusted it now. We adjusted it in the meantime at Homestead, right?
Okay, oh, that's good. Let's see here. I came across this tweet the other day, actually, of from Sergio Demon Lerner.
Cool.
I hope the next hard fork of Ethereum fixes the money supply function. It is broken. Miners can collude to create more ETH. Should use Decore Plus. So I think he's referring to like miners can collude to create more uncles, which in turn would create more Ether being produced.
Totally. Yep. I think that is vulnerability, and I've been concerned about that for a while. Although we do have a very because we had this concern, we put a bound on how many uncles there can be. Right. We can only have 2 uncles per height, I think. Let me just check. I'm pretty sure that's what it is. 4 uncles per height. So that is significant. Like basically, we could have potentially somewhere between 4 and 5 times as much Ether issued as if there are no uncles. I think that's terrible. I agree. I think we're issuing way too much Ether to miners, and I think we'll hopefully find clever ways to transition proof of stake as quickly as possible to not have this big vulnerability, which is essentially the miners.
Okay. No, that definitely answers my question. So you guys are gonna try and nip that as soon as possible. But it's good that it's in full knowledge of the foundation.
Oh yeah, of course. Yeah, I mean this has been something that we've done for a long time.
What was that, Kiko?
Just asking if he can wait another month for my graphics card to pay off.
I'm not waiting for you, pal. But it doesn't mean you won't have time, but I can't guarantee anything.
We had you on the line.
So I'm getting to the bottom of my barrel of questions here, unless someone at Decentral has another question.
I was kind of wondering, Vlad, which other crypto projects outside of Ethereum have you been following, and why?
That's a good one. I follow Bitcoin, I guess. I follow some of the things in Bitcoin. I follow Tendermint. What I really am into is, going around and hanging out with individual researchers and people who are in the space who are really know their stuff and who have a lot of relevant background experience. Much more than I've liked to follow projects. I think that the market can support and will support basically a small handful of blockchains with a large market cap, and then a very large number of small blockchains. I think that basically, just like pretty much every market, we're going to see that it's going to be quite oligopolistic. So I spend most of my time just thinking about how we can make Ethereum provide guarantees to clients, even in the worst case.
I have a question. What's the current state of oracles in Ethereum? Are there things going on in the wild where you can tap the real world into contracts?
I hear that people are working on this stuff. I am definitely not that level of the stack at the moment. Which I'm basically saying that I don't know.
It's amazing that field is still so wide open, even in Bitcoin.
I mean, I don't know. I don't really follow. I mean, I've heard of a few people working in oracles, but if you can provide some true data feeds to some contracts, maybe it's a business plan for you.
I got 2 more questions, but the one you don't have to answer, it was probably more of a joke. It says, is Vlad single?
Great. Yeah, I am. I don't mind. Not embarrassed.
Well, I hear Vitalik is engaged, so maybe he'll be signing his prenup in an Ethereum
I
contract.
haven't heard that. I don't think that's true. If it's true, he hasn't told me.
Oh, okay.
Over the internet.
I mean, not that he necessarily would, but I mean, I would hope that I would find out.
Okay. And the last question I got here is, do you value your Ethereum in USD or in BTC?
Jeez, USD. I mean, I actually think that the thinking about the price, and I mean, I just wish all cryptocurrencies were $1 always forever, because then we could start, then it wouldn't be such a big distraction, and people wouldn't need to like, start new chains to compete, or just because they want their own cryptocurrency, right? They could like work on starting new chains only if it's got actually some interesting tech, right? But yeah, so I don't know. The price of Ether going up is definitely a mixed blessing, right? I mean, the additional attention, the increased size of the community, all these things don't really like help us push tech, but it does in some sense, because it makes it harder to coordinate and means more people are involved in the arguing, and there's more eyeballs, so that everything has to go more slowly as a result. But it also means that we have an opportunity to have like a wider community of people who are educated and interested and willing to contribute.
Somehow you have to get from 0 to 6 billion, though. Like, you can't really skip that step. Like, Bitcoin couldn't have launched at 6 billion and then, just stayed there.
I mean, I don't know. I can't really comment on that.
One question. Have you heard anything about like DApp Hub that Consensus is working on?
No, I don't know anything about that.
And we're done.
Awesome. Thanks, Vlad.
Cheers, Zach. Thanks for setting this up.
So we have a tradition as how we wrap up every show is we get our guests or everyone participating in the show and basically predict what Bitcoin is going to be in a week's time, what price. So let me just get the screen shared here, and we'll get right on to her. I'd ask you what you think Ethereum price is going to be, but I don't want you to be a victim of insider trading, so we'll keep it kosher. All right, so let's see here. Right now we are at 415 on a little dip, and Vlad, what do you think the price of Bitcoin will be next Tuesday at 7 o'clock Pacific time?
I think it's going to be 415.70.
415.70, all right.
Yeah.
You're probably pretty right. We've been bouncing around in this triangle pretty well. I'm going to go a little higher at 420. And since we got so many people at Decentral with fans, I think I'm just going to have to hear you guys shout out numbers.
423.
423.
Me too.
Is that the consensus of the room there? Is everyone says 423?
I'm optimistic. 450. 450 from Ren.
450, okay.
So the halving is coming.
So
Are you going to celebrate the halving, Vlad?
Yeah, I mean, I guess I'll probably send some tweets out, retweet some things. It's going to be great.
You realize it's going to be 4th of July weekend?
No, I didn't realize that.
Get the fireworks going.
I got one more question. Can entropy be reversed?
Yes.
All right, well, awesome. Thanks so much for coming, Vlad. It was a great show, and I was so glad to talk to you.
Cheers, yeah, it's been fun.
And we're also hopeful in what Ethereum is doing and the development that they're pushing forward with. It's definitely the most excitement we've seen in the space in recent times. So we really appreciate the hard work you guys are doing. And for everyone watching, be sure to like and subscribe. Follow Block_talk on Twitter. Check out next Tuesday, I believe. I haven't confirmed quite yet, but we will be most likely interviewing Augur and maybe doing these Bitcoin price predictions on their beta platform. So super excited for that. Mark the calendars and check it out. Follow, like, subscribe, do all that fun stuff.
Sweet. Yeah. Shout out to Augur for giving me a grant to work on Casper, by the way. It's pretty awesome.
Oh, yes. So, yeah, on that note, thanks everyone for watching, and see you sometime in the next 1,000 blocks.